Mixture problems can also be solved in a slightly different way. So this solution that's shown here, this is using a system of equations, but we can solve these mixture problems using a proportion. So looking at this number line here, this is our low amount, this is our high amount, this is our mixed amount. And we can solve this using the proportion by looking at these differences. So in this case here, the difference here is going to be 0.7 molar, and the difference here is going to be 1.4 molar. And this ratio of these differences ends up being a 1:2 ratio. So that means then that if I want to make it closer to the 3.2 molar, I need more of the 3.2 molar solution. So I'm going to have 2 parts of the 3.2 molar, and I'm going to use 1 part of the 5.3 molar. Okay, so it's in reverse because if we want it to be closer to the smaller amount or the smaller difference, we need to have more of it. So the proportions are reversed when we talk about the volume. Okay, so it's an inverse relationship. So we end up with, since we have to split up 900 milliliters into 3 parts, we're going to have 1 part, or 300 milliliters of the stronger solution, and 2 parts, 600 milliliters of the weaker solution. And so we can use this proportion to solve a problem like this when we talk about these mixture problems with concentrations, or with the percentage concentration problems. These type of problems can be solved using a proportion in this way. They can also be solved using a system of equations. Okay, if we're not sure how to use this proportional method, we should really stick with a system of equations.